Section 1.2, the order of operations. Here are the order of operations. 1, I want to simplify inside grouping symbols first. Our grouping symbols can be parentheses, brackets, braces, and even absolute values when we get to that point. Number 2, multiply or divide in order from left to right inside the expression. And then number 3, we want to add or subtract in order from left to right inside the expression. Here, what we want to do is take a look at our grouping symbols. Notice I have 3 times 12, that's 36. 3 times 12, still 36, and 3 times 12, here again, 36. But notice I have parentheses, brackets, and braces. Essentially all the same thing. They look different, they are just different forms of grouping symbols, and in each case, they mean multiplication. Here's a procedure that we want to use when solving order of operation problems. Number 1, I want to copy the problem from the book. Number 2, I want to work down the problem. Don't work to the right. Don't write your sample problems to the right of it. Work down the page. A, do not write to the right of the problem. B, write below the problem. And C, use a lot of space because we don't want to make mistakes. So, for example, if this was our problem in the book, I would just take number 1. I would then write 22 minus 3 times 5. There are no grouping symbols, so now I want to work from left to right, and I have to do multiplication and division first. So I'm going to bring down my 22. I just recopy that, bring down my minus sign, and then 3 times 5 is 15. Now I simplify. I do addition and subtraction in order from left to right. 22 minus 15 leaves me an answer of 7. So notice I copied the problem from the book. I worked down the page. I did not write my answers to the right, and I took a lot of space so I could actually see everything that I'm doing, and I can go back and look at everything that you're doing also. Here I want to simplify each expression using the order of operations. Again, if this was in the book, I'd copy this problem down, work down the page. 8 plus 12 divided by 4 is 3, because I'm going to do multiplication and division in order from left to right. Now 8 plus 3 is 11. Here on number 2, I have 3 times 4 plus 6 plus 8 over 2. I bring down my 3 times 4, which I know is 12, plus, and here, this is essentially a grouping symbol on top. I have to find the sum of these two numbers before I can divide by 2. 6 plus 8 is 14, divided by 2. I'm going to bring my 12 down again, plus 14 divided by 2 is 7. 12 plus 7, 19. Notice on each problem, working down the problem, using a lot of space. Again, I want to simplify. Here I have a set of grouping symbols, so I want to copy everything down. Bring down my 2. And then I work inside my grouping symbols first. 9 divided by 3 is 3. I bring down my 5, plus 2 times 3 is 6. 5 plus 6, 11. Number 4, 16 plus 14 all over 8 minus 5. I'm going to work on the top and the bottom separately and then simplify at the end. 16 plus 14 is 30. 8 minus 5 is 3. Now I find the quotient. I want to divide. 30 divided by 3 is 10. Still simplifying, number 5. I'm going to work from left to right and do multiplication in order from left to right. I bring down my 3. Multiplication and division in order from left to right. 8 times 3 is 24. Divided by 12. Notice I work on 2 numbers at a time. That's it. I don't try to solve any faster than this. Bring down my 3. Plus 24 divided by 12 is 2. And finally, 3 plus 2 is 5. Number 6, I have 2 sets of grouping symbols. I have a set of brackets and parentheses. I basically am going to copy the whole problem down. Bring down the 20, bring down the plus sign, bring down the brackets, bring down the 3, the plus sign, and finally the last bracket. So all I'm going to do out of this whole problem is this little piece right here, which is 8 minus 3. And 8 minus 3 is 5. Now I'm going to recopy the whole problem again. That's going to give me 20 plus, I can even copy the brackets if need be, and this is going to be 3 plus 5, which is 8, and 20 plus 8 is 28. Continuing, I have number 7, again, a bunch of grouping symbols. I'm going to copy all this material down, 3, bring down the 4, the plus, the 2, the parentheses, the bracket, and the 20. All I did is copy most of the problem down. All I'm going to work on now is 6 minus 4, which is 2. Again, I'm going to copy everything down, 3 plus, and the minus 20. And now I'm going to perform this operation. Since I'm inside this grouping symbol, I have to do multiplication before I can add. 2 times 2 is 4. And I still have the plus sign. Bring down the 3, the brackets, and the minus 20. Notice I'm reducing the problem. I'm simplifying. Now I work inside my brackets, my grouping symbols. 4 plus 4 is 8. And now I have 3 times 8. So 3 times 8 is 24, minus 20. And my final solution is 24 minus 20, which is 4. Similar problem number 8. Again, a bunch of grouping symbols. Again, relax and just copy what's in this problem. And all I really want to work on is that little bit. Even though it looks very big, I want to work on that little piece. Bring down my 30, minus 2. Bring down to 3, plus 3, parentheses. So in this type of situation, just like on this one, I want to work on the inside out. So all of this, all I did is copy all of that material. I'm just going to go 7 minus 4 is 3. Now I'm going to copy everything down again. 30 minus 2, 3 plus, minus 6. And all I'm going to do is this little piece, 3 times 3, which is 9. Bring everything down again. 30 minus 2, and the minus 6. And inside my brackets, 3 plus 9 is 12. Now I bring down my 30, minus, comes down, 2 times 12 is 24, minus 6. 30 minus 24 is 6, minus 6, and my solution is 0. On this problem, I want to write 2 expressions you could use to find the area of each shaded figure. Then I want to find the area. Let's begin by breaking this L-shaped figure into 2 pieces that I can find the area of. What I can do is break this here and find the area of this piece and add it to the area of this piece. And since they're both rectangles, I know that the area of a rectangle is going to equal length times width. I'm just going to have 2 of them. So let's determine the dimensions of this piece here. Since this is 2 and the whole piece here is 10, that makes this piece from here to here 8 centimeters. So now the first rectangle has a length and a width, which I know is going to be 1 centimeter by 8 centimeters. I'm going to add that to the bottom one, which I know is going to be 2 by 4. And then I simplify using order of operations. Multiplying gives me 8, plus multiplying gives me 8, gives me 16 centimeters squared. And it's squared since I have an area. In other words, 2-dimensional space. Now, let's work on that same problem, but use a different method. What I plan on doing here is assuming that now I have one entire block, one big rectangle, and I can find the area of that rectangle and use this formula. Area of the shaded equals area of the total minus area of the missing. Area of the total would be assuming that this was a complete rectangle without this chunk missing. So to find the area of the total, I'm just going to take the length times the width, which is going to be, we know, again, length times width is going to give me the area of that rectangle, so it's going to be 10 by 4, minus the chunk that's actually missing. And here, I know that this chunk, as determined from the previous page, is 8 centimeters. 10 minus 2 is going to give me this piece. And now, 10 minus 2 is 8 centimeters, and I know the whole length is 4, but I only want this piece here. And this is 1, so 4 minus 1 gives me 3 centimeters. So the missing piece is 8 by 3. And when I figure this out, this is going to be 40. 10 times 4 is 40, minus 8 times 3 is 24. And 40 minus 24 is going to give me 16 centimeters squared. And if I go back and look, again, I get the exact same value. And I should, since it's the area of the same figure. Let's continue on to the next page. I want to find, again, I want to find two methods of determining the area of the shaded region. Let's do the last method that we just did here first, which is the area of the shaded equals area of the total minus area of the missing. So I'm going to assume that this whole block is shaded in. And to do that, that's going to give me the area of the total. And I know the total piece is going to be 7 by 7. Minus the area of the missing, which I know is 2 by 2. Order of operations, 7 times 7 is 49. Copy down the minus sign. 2 times 2 is 4. Subtract, and I get 45 meters squared. Now I have to use the second method, which is to break up my shape into chunks. And to do that, I started with the red writing, which is up in this section of my figure. I cut it in this direction, and that's going to give me a length of 7. And since I know that this is 1 and 2 here, that tells me that this has to be 4 meters up here, not centimeters. So that's 4 and 7. Then I did the green section, which is going to give me 3 meters, as I've already found over here. And I already know that this is 1 meter. So that's going to give me 3 by 1. And then my golden section or yellow section is over here. And I know that, again, this is 3. And I know that this is 1 and 2. So 1 and 2 is 3. 3 from 7 gives me 4 meters. So that gives me a section of 3 by 4. Then I have this tiny little piece right here. And I know that since this is 1 and this is 4, that gives me a length of 5. And that tells me that this piece here is 2 meters long. And I already know it's by 1, 2 by 1. Now, by order of operations, 7 times 4 is 28. That gives me 3, 12, and 2. And then finally, I find all their sum, and I get 45 meters, just as I did on my previous one using the other method. And finally, my last problem is I want to write a word problem for the numerical expression. Basically, I just want to make this up. And I can see this as expression is 4 times the quantity of 4 plus 2 minus 3. And I just want to make up any type of story that could make this fit. Therefore, I could assume this type of situation. Here I have 4 farms. And in each farm, I have 4 horses, 4 horses, and 2 chickens. And then one day, one farm lost 3 horses. And then I could find the total number of animals. Therefore, I just made up a story that would actually fit this expression.